greatest common factor and factoring by grouping. So first off, when we talk about the greatest common factor, we commonly will use just GCF. What this means is it's the largest factor that all those numbers have in common. One way to think about it is what number can all of these numbers be divided by evenly? And then you also have to look at the variable. So how many of the same variable or variables plural do they all have? So we're going to start by just finding the GCF of these three numbers. So the strategy I'm going to use here to go through it, you don't necessarily have to do this the whole time. You could look at the numbers and see what the largest number that divides all of them. But one way you could do this is we could say, okay, well 48 is 8 and 6, which is 4 and 2, 2 and 2, and 3 and 2. So 48, we've got 1, 2, 3, 4, so 2 times 2 times 2 times 2 times 3. I'm going to go ahead and erase this so we can do our 12. 12 is 2 times 6, which is 2 times 3. So 12 is 2 times 2 times 3. Once again, I'm going to go ahead and erase this so I can do the factor tree for 20. Let's go with 4 and 5, which is 2 times 2. Now let's look. They have to have the same numbers in common, so they all have a 2, and they all have a second 2 in common. So the GCF is 2 times 2, or 4. And like I said, some people could look at these three numbers and see 4 is going to be the largest number that divides all of them, and that's fine. But if in doubt, you can always do it the other way. Alright, now let's look at these. So the largest number that can divide all of these is going to be a 3. And now let's look how many x's do they all have. Well, this has 3 x's, this one has 3, and this one only has 2. So they all have at least 2 x's, or x squared. And then this has 3 y's, 1 y, and 2 y's, so they all have at least 1 y. So your GCF would be 3x squared y. Now, when we talk about factoring, so when the directions say to factor, that means you're going to start by dividing each term by the GCF. Essentially, it's backwards distribution. So it's the opposite of what we did when we would distribute before. So let's start here. And looking at 9 and 12, our GCF is going to be 3. But we also can take out 3 x's and 2 y's. So when we divided that out, 9 divided by 3 is 3. We took out 3 x's, so we're left with an x. And we took out both y's here, so there's none left. And then we had negative 12 divided by 3, so negative 4. We took out all 3 x's. And we took out 2 y's, so that means there's going to be 1 y still left in here. Alright, now looking here. Our GCF, if we look at just our numbers, is going to be 2. And now look as far as A squared and B. That's our GCF. So let's look at what we have left. In this first one, we divided out the 2, so that'll become a 1. We took out 2 of the a's, so there's still 2 of these a's left, or a squared. And there's still b squared left. In the second one, we divided by 2, so we're left with 3. We took out 2 of the a's, so there's 1 left, and we took out 1 of the b's. On the last one, negative 2 divided by 2 is negative 1. We took out the a squared and the b, so we're just left with negative 1. On this next one, the GCF of all of these is just 1. There's no largest factor we can divide out from all of them, so we call this prime. There is no GCF. We cannot factor. Alright, now this last one. Notice they both have this factor in common, so we can divide that out from both of them. And what was left in this first one is an x, and what's left in the second one was that negative y. Another way to look at this would be, coming from this beginning, we could say, alright, let's just call it a different variable. Let's just say this whole thing, let's just call it something else. Let's call it m. So we would actually have x times m minus y times m. Well, now your GCF that you can take out is m, and we're still left with the x minus the y. But we had this as our substituting for m, so instead of m, we'd have a plus b plus c times x minus y. And notice these are the same thing, which is what we want. So it doesn't matter which way you do this. It's whatever way you can see. Alright, so now we're going to do factoring by grouping, which is essentially what we were just doing at the end. So the key thing here is to find a way to group your terms so that when you factor the GCF from two pairs, what you have left in your parentheses is the same. So in this first one, usually it's easiest to pick the first two and the second two, but that doesn't always work. So notice these both have a u in common, so that should be a hint. We could probably factor that u out and get it somewhere. So factoring that u out. Now in these two, they both have a v in common, so we'll take out a positive v. And now notice they both have this x plus y factor, and so let's factor that from both. And we're left with this u plus v. So here's our answer. Same thing here. Notice though if we grouped the first two, they don't have any common factors, so that's not going to help us. So let's try maybe doing these two. Notice they have a common factor of x. So when we take that x out, we're left with x minus y. And when we then factor these two together, we can take out a 4. I'm taking out a positive 4, so we're left with y minus x. Now notice these aren't quite the same, but they're very similar. They're only off by a factor of -1. So let's actually factor a -1 out of this piece in the back. So we'll have our x times x minus y. And if we factor out a -1, this will become -4, and this will become -y plus x. We factored out a -1. Now, notice this is the same as this. They're written in a different order, but both of them are x minus y. And so now that is the same, so we can factor that from both, and we're left with this x minus 4. Alright, same idea here. Let's start with the first two. The GCF is going to be 2x. We're left with 3x minus 5. But notice these second two don't have a GCF, so that one's not going to work. So that's not going to work. What about if we did these two? And then, so let's start with taking a -5 out. We're left with -2x plus 1. Notice here we're dividing a -5 by -5, so it's a positive 1. And then when we group these two, we can take out an x, and we're left with 6x plus 7. Well, these still aren't the same, and those are their only options for grouping. So if this doesn't work, then it's prime again. If there's nothing we can do, we can't factor. Alright, let's look at this one. Well, these two have an a, so let's try that. We factor out the a, we're left with 4 minus x. In the other two, they both have a 7, so let's take out a positive 7, and we're left with x minus 4. Well, once again, they're similar, but they're off by that negative. So let's factor out a negative here and change this to negative 7. This will be negative x plus 4. And now notice these are the same. So we can factor this negative x plus 4 from both, or 4 minus x, however you want to write it. And we're left with the a minus the 7.